Good morning, students.
Good morning, sir.
Welcome to our class. Now, today we are going to discuss about the work energy theorem. This question is here: work energy and power. Question: these three questions important, very important in IPE, TS and AP. దేనికి సంబంధించినవి? TS and AP. Most important, 8 marks. Listen carefully. 2 questions in this academic year. 2 very important questions: work energy theorem and law of conservation of energy in case of freely falling body. Now we are going to discuss about the work energy theorem. Here question is, ఇందులో మనకు చూసినట్టయితే 6th టాపిక్లో 3 లాంగ్ ఆన్సర్స్ ఉంటున్నాయి. అందులో ఒకటి ఎలిమినేట్ చేయడం జరిగింది సిలబస్ నుండి, అది కొలిజన్స్. ఇయర్ రిమైనింగ్ క్వశ్చన్స్ ఇయర్, హౌ మెనీ క్వశ్చన్స్ ఇయర్? 2 questions. Okay, these 2 questions in IPE. Recently these 2 questions in IPE ఇవ్వడం జరిగింది. సో చాలా జాగ్రత్తగా వినండి. ఓకే, ఫస్ట్ ఆఫ్ ఆల్ ఇయర్ క్వశ్చన్ ఇస్ ఫస్ట్ క్వశ్చన్ ఇన్ లాంగ్ ఆన్సర్. ఓకే, వర్క్ ఎనర్జీ అండ్ పవర్. వర్క్ ఎనర్జీ అండ్ పవర్. First question in long answer question. See here, develop the notations of work and kinetic energy and show that leads to work energy theorem. Leads to work energy theorem. First of all, define the statements. First of all, define the statements. What is the work? What is the kinetic energy? What is the work energy theorem? First of all, listen. వాట్ ఈజ్ ద వర్క్? స్టేట్మెంట్ హియర్, పని అంటే ఏమిటి, అదేవిధంగా గతిశక్తి అంటే ఏమిటి, పని శక్తి సిద్ధాంతం అంటే ఏమిటి, ఈ మూడిటికి ఫస్ట్ ఆఫ్ ఆల్ స్టేట్మెంట్స్ చెప్తా వినండి. ఫస్ట్ ఆఫ్ ఆల్, వర్క్ ఈజ్ డిఫైన్డ్ యాజ్ సింప్లీ ఇఫ్ ఏ బాడీ డిస్ప్లేస్డ్ ఫ్రమ్ వన్ ప్లేస్ టు అనదర్ ప్లేస్, by the external force acting on the body, then the work is said to be done. Okay, once again, if a body displaced from one place to another place by the external force acting on the body, then the work is said to be done. Okay, it is called as here just work. The work denoted by W is equal to here force into displacement. Okay, here work is a scalar quantity. The dimensions of the work is a ml square t inverse to the SI units of the work here joules. Okay, first of all, statement here, what is the work? Heading, note this one. Okay, statement here, if a body displaced from one place to another place. Okay, another place by the external force, on a external force acts on a body is known as work. Okay, another statement here, work is defined as the product of force vector and displacement vector. ఇక్కడ ఇంకొక ఫార్ములా ఏంటంటే బలానికి మరియు స్థానభ్రంశం మధ్య లబ్ధాన్ని ఇక్కడ మనం వర్క్ అని చెప్పవచ్చు. ఓకే, హియర్ వర్క్ ఈజ్ వర్క్ ఈజ్ ఈక్వల్ టు force into displacement. Okay, displacement, that means here that is equal to here F dot S. The work denoted by capital, this is denoted by W, this is denoted by here W. This F dot S, it is a scalar quantity, That means here work is equal to Fs cos theta. Fs cos theta. This is a work. It also SI units. SI units here joule. SI in joule. Dimension formula also here. Dimensional formula M L square T inverse 2. Enough. This matter enough from the just to work. Okay. Next, what is the energy? Kinetic energy. What is the kinetic energy? The kinetic energy is defined as just the body. The energy passes by a body by virtue of its motion. By virtue of its motion is called as kinetic energy. Is called as a kinetic energy. Once again, the energy passes by a body by virtue of its motion is called as kinetic energy. అంటే ఒక వస్తువు తన గమనం వల్ల పొందే శక్తిని గతి శక్తి అంటారు. ఏమంటారు? ఒక వస్తువు తన గమనం వల్ల పొందే శక్తిని ఏమంటారు ఇక్కడ? గతి శక్తి. దీన్ని మనం ఇంగ్లీష్లో ఏమంటారు? ద ఎనర్జీ పాసెస్డ్ బై ఏ బాడీ బై వర్చ్యూ ఆఫ్ ఇట్స్ మోషన్ ఈజ్ కాల్డ్ యాజ్ kinetic energy. So here kinetic energy is a scalar quantity. Kinetic energy is a scalar quantity. Okay. Now for example of the kinetic energies, all moving vehicles are all moving bodies having kinetic energies. అంటే గమనంలో ఉన్నటువంటి అన్ని వస్తువులు కూడా ఏ శక్తిని కలిగి ఉంటుంది? ఇక్కడ గతి శక్తిని కలిగి ఉంటుంది. ఫర్ ఎగ్జాంపుల్ ద ఫ్లోయింగ్ వాటర్ ఇన్ ఏ రివర్. ద ఫ్లోయింగ్ వాటర్ ఇన్ ఏ రివర్. ద ఫ్లయింగ్ బర్డ్స్ ఇన్ ద స్కై. దీస్ ఆర్ హ్యావింగ్ kinetic energy. Okay, these are having a kinetic energy. First of all, note this one first. Statement kinetic energy. Okay, statement చెప్పండి. Kinetic energy means the energy passed by a body. The energy passed by a body. Tell me. The energy passes by a okay by a body by virtue of by virtue of its motion. Its here motion is called is motion. Okay, this is a is motion is called here is known as simply is known as kinetic energy. Is known as a kinetic energy. Very very important question. Statements ki statements 2 marks vastayamma. Two statements ki 2 marks untayi. It is known as a kinetic energy. The kinetic, that is the kinetic energy of the body. Kinetic energy here K is equal to 1/2 mv square. 1/2 here mv square. This is a kinetic energy. The SI units here SI units here SI units means joule. SI units here joule. Okay, joules. Dimensional formula m L square T inverse 2. These are enough matter. This one here. So examples: the running vehicles having kinetic energy, and the flowing water in a river, the flying birds. These are having the kinetic energy. Examples రాసినట్లయితే అవి రాయండి సరిపోద్ది. ఇక్కడ ఫస్ట్ స్టేట్మెంట్ వర్క్ స్టేట్మెంట్ రాయండి. అదేవిధంగా ఏది రాస్తారు ఇంకా kinetic energy. Now kinetic energy formula here, work energy theorem statement, work energy statement. The force ఇక్కడ ఏం రాద్దామంటే సరే దీంతో కంటిన్యూషన్ చేద్దాం. నోట్ దిస్ వన్ ఫస్ట్ ఆఫ్ ఆల్. ఓకే, now work energy theorem. Heading work energy theorem. Okay, work energy theorem. Now work energy theorem means here work is equal to of m v square minus here of m u square. We prove this formula. This formula. This is the work done by the force. The work done by a force on a body is equal to change in kinetic energy. Change in kinetic energy of the body. This is the work energy theorem. This is called a work energy theorem. Statement here, the force ఏం రాద్దాం స్టేట్మెంట్ బలం వలన జరిగిన పని అనేది ఆ వస్తువు యొక్క గమనం అయింది గతిశక్తిలో మార్పుకి సమానం. అంటే బలం వలన జరిగిన పని వస్తువు పొందినటువంటి గతిశక్తిలో మార్పుకి సమానం. దీన్ని ఏమంటున్నాం ఇక్కడ గతిశక్తి సిద్ధాంతం అంటున్నాం. ఓకేనా. నౌ నోట్ దిస్ హియర్ ఎక్స్ప్లెనేషన్. ఫర్ ఎగ్జాంపుల్ this is a surface, this one here surface. Okay, the mass of the body, for example m, the mass of the body here m. Okay, the external force acting on this body, this body f. Okay, this body traveling with uniform acceleration a, okay, its initial velocity u, okay, and its acquires final velocity v after traveling through a distance here distance s. అంటే ఇక్కడ ఏంటంటే ఈ దీనిపైన f అనే ఫోర్స్ని అప్లికేషన్ చేస్తే ఎంత డిస్ప్లేస్మెంట్ ఇది త్రూ ఏ displacement here this is moving in with uniform acceleration here a. Okay, initial velocity here u, final velocity v. Its final velocity v, initial velocity u. This f means external force acting on this body. Here s means displacement through from a to, for example here a to b. Okay, this body moving with uniform acceleration a. Okay, this is a matter. Okay, right. Let us consider work energy theorem. Let us consider a body of mass here small m moving or traveling with uniform acceleration a, uniform acceleration here a. Okay, this is a uniform acceleration in matter randi, uniform acceleration a. Let us its initial velocity, its initial velocity here, initial velocity v, which value is here u. Okay, initial velocity u, and here and its final velocity, it acquires here, it acquires final velocity here v, through a displacement here, through a displacement ఈ matter అండి displacement here displacement yes. Okay, this matter enough matter, this is a enough matter. Once again, let us consider a body of mass m traveling with uniform acceleration a. Let us its initial velocity v u and its acquired final velocity after some time through a displacement here yes. Now according to the third equation of the motion, అంటే మూడవ చలన సమీకరణం నుండి from the note this one from here according to third equation of motion. Here third equation of motion, v square minus u square is equal to 2as. v square minus u square is equal to 2as. Okay, v square minus here u square is equal to 2as. This is the third equation of the motion. This one here, third equation of the motion. First of all, note this one. Okay. V square minus u square is equal to 2as. Tell me. Now, this equation multiplying on both sides by m by 2. m by 2. దేంతో మల్టిప్లికేషన్ చేయాలి దీన్ని m by 2 on both sides. Okay, here continuation v square minus u square is equal to 2as, multiplying on both sides with here multiplying on both sides here with here which value is here m by 2. Okay, this is a m by 2 above the equation. Now m by 2 into this one v square minus u square is equal to, tell me, m by 2 into 2as. Any terms cancel?
2 cancel.
Here 2 get cancelled. 2 m get cancelled. That is equal to this multiplying inside 1 by 2 m v square minus here 1 by 2 m u square. That is equal to here m a s. That is equal to here m a s. But the Newton's second law, according to Newton's second law, F is equal to ma. Here this one, this continuation according to Newton's second law of motion. 8 marks, very very important. Law of motion. Here F is equal to ma. F is equal to here ma. So above equation simplifies here of m v square minus of m u square is equal to ma into here just s, ma into s. Okay, this is equal to, this one is equal to f. This is simplifies here 1 by 2 m v square minus here 1 by 2 m u square is equal to m fs. This is a fs. But definition, according to definition here work is equal to fs. Initially already mundu rashna kada. Now note this one here. This is a according to here definition here w is equal to here fs. W is equal to s. So this equation, note this one, very very important, most important in IPE. Okay, tell me, final velocity minus initial velocity, final kinetic energy minus initial kinetic energy, that is equal to here that one. This is a according to okay of m v square minus of m u square, that is equal to here this one w. This is equal to w. So this above equation in case of the body traveling along the one dimension, that means here x-axis, here in this case this is a left terms above equation, left terms first term means here this is the first term represents here final kinetic energy of the body, and second term of the left side gives here initial kinetic energy of the body. Here right term indicates here work done by the body. ఇక్కడ వరకు మనం రాసినట్లయితే మనకి ఏమి వస్తుంది, ఇక్కడ మనకి 8 మార్క్స్ వస్తుంది. ఓకే, నౌ దిస్ above equation ఓకే ఇది రాయండి. above equation in case of a body one dimensional motion, In case of body, holds good. Here holds. Then part is nama holds good here. One dimensional motion. Here one dimensional motion. Okay, that means enter manaki here dani endi, that means along the for example along x axis, along here along x kada, x axis along here x axis. ఇది ఏకమితీయ చలనానికి సంబంధించి ఏంది ఏకమితీయ చలనం in 3 dimensions. After we will 3 dimensions means the body, when the body moving along the in space, that means 3 dimensions at a time. ఒకే కాలంలో 3 దిశలలో ఆ వస్తువు గమనించినప్పుడు దానికి ఏం అప్లికేషన్ చేయాలి, వెక్టార్ అప్లికేషన్ చేయాలి. దేని అప్లికేషన్ చేయాలి ఇక్కడ, వెక్టార్ అప్లికేషన్. సో ఇక్కడ వాటిని రాసి సరిపోద్ది మనకి. ఓకే, లాస్ట్ ఫైనల్లీ ద వర్క్ done by a force on a body is equal to here change in kinetic energy, so ఇప్పుడు రాయండి వర్క్ ఎనర్జీ థీరం. here note this one, వర్క్ ఎనర్జీ థీరం స్టేట్మెంట్ ఏంటి, వర్క్ ఎనర్జీ థీరం. టెల్ మీ the work done by the force, work done by a force on a body is equal to change in kinetic energy, here finally work is equal to half mv square minus here half mu square. Here k e f is equal to final kinetic energy, this one here final kinetic energy, and k I, this is a initial kinetic energy, now here work energy theorem statement. Note this one, here work energy theorem, the work done by the force on a body is equal to change in kinetic energy, లాస్ట్ స్టేట్మెంట్. ఈ స్టేట్మెంట్కి 1 మార్క్ వస్తుంది మనకి లాస్ట్ ఫైనల్లీ, లేదా దీన్ని ముందు రాసిన పర్వాలేదు మనకి. ఓకే, వర్క్ ఎనర్జీ థియరం స్టేట్మెంట్, ద వర్క్ డన్ బై ఏ ఫోర్స్ లేదా ద ఎక్స్టర్నల్ ఫోర్స్ యాక్టింగ్ ఆన్ ద బాడీ, అదేమవుతుంది, దేనికి ఈక్వల్ అవుతుంది ఇక్కడ, కెనెటిక్ ఎనర్జీకి ఈక్వల్గా అవుతుంది. సో ద వర్క్ డన్ by a force on a body, it is equal to its kinetic energy, change in its change in kinetic energy. This is a work energy theorem. This one here work energy theorem. ఇక్కడ వరకు మనకు రాస్తే 6 మార్క్స్ వస్తాయి. ఎంత వస్తాయి, హౌ మెనీ మార్క్స్ గివెన్ ఇన్ క్వశ్చన్ పేపర్, 6 మార్క్స్. అడిషనల్ ప్రాబ్లం ఉంటుంది, అడిషనల్ ప్రాబ్లం కూడా చేస్తే మనకి 2 మార్క్స్ వస్తాయి. ఓకే, నోట్ దిస్ వన్. నెక్స్ట్ వన్, వర్క్ ఎనర్జీ థియరం, లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ కెనెటిక్ ఎనర్జీ, ఓకే. Note this one. Okay, next one, see here first question here, work energy theorem. Now that is the very most important in IP. Now second one here, law of conservation of energy, in case of the freely falling body, first of all law of conservation of energy statement. Listen first here, the total energy of the system, the total energy of the closed system always remains constant, but it can neither be created nor be destroyed, but one form of the energy converted into another form, అనదర్ ఫామ్. దిస్ ఈస్ కాల్డ్ యాజ్ ఎ లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ. అంటే ఇక్కడ ఏంటంటే విశ్వంలో ఉన్నటువంటి మొత్తం శక్తి స్థిరం. విశ్వంలో ఉన్నటువంటి మొత్తం శక్తి స్థిరం. ఈ శక్తిని సృష్టించలేము, నాశనం చేయలేము, కానీ ఒక రూపం నుండి మరొక రూపానికి మార్చవచ్చు. ఒక రూపం నుండి మరొక రూపానికి మార్చవచ్చు. ఓకే, నౌ స్టేట్మెంట్ వన్స్ అగైన్. ద టోటల్ ఎనర్జీ ఆఫ్ ద క్లోజ్డ్ సిస్టమ్, ద టోటల్ ఎనర్జీ ఆఫ్ ద క్లోజ్డ్ సిస్టమ్ ఆల్వేస్ రిమైన్స్ కాన్స్టాంట్. It can created nor be destroyed, but one form of the energy converting into another form. For example, the mechanical energy converting into here heat energy, sound energy, etc. So first of all, mechanical energy, the sum of the potential energy and kinetic energy is called as here mechanical energy. దాన్ని మనం ఏమంటున్నాం, టోటల్ ఎనర్జీ. అంటే గతి శక్తి స్థితి శక్తుల మొత్తాన్ని యాంత్రిక శక్తి అంటాం. గతి శక్తి స్థితి శక్తుల మొత్తాన్ని ఏమంటాం ఇక్కడ, యాంత్రిక శక్తి. నౌ లిసన్ ఫస్ట్ ఆఫ్ ఆల్ క్వశ్చన్ హియర్. స్టేట్ అండ్ ప్రూవ్ లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ ఇన్ కేస్ ఆఫ్ freely falling body, in case of here freely falling body. First of all, statement, note this one statement here. The total energy is statement here. Statement means law of conservation of energy. Heading em petali, law of conservation of energy. Statement here, the total energy, the total energy of a closed body, closed body or closed system, దీన్ని ఏమంటారు ఇక్కడ, closed system. ఓకే, always remains constant, remains, tell me, constant. Okay, it can neither be, it can here neither be created, neither be created nor be destroyed, nor be here destroyed. Okay, nor be destroyed, nor be destroyed, but one form of the energy converted into the another form, here destroyed, but here but one form of energy, one form of energy converted into another form. Okay, this is a law of conservation of energy. This is called as here law of conservation of energy. Now first of all, no statement. This statement ki 1 mark vastundi manaki. It is statement ki vastundi marks 1 mark. Now total energy, total energy nothing but here the sum of the potential energy and kinetic energy. It is called as here total energy. That means here mechanical energy, continuation as there and long answers ki. So heading mechanical energy, mechanical energy is statement here, the sum of potential tell me, potential energy and kinetic energy, and here and kinetic energy. Okay, potential energy and here kinetic energy is called here mechanical energy, is called here mechanical energy. Okay, mechanical energy. That means here this is called also total energy. This is called also here total energy. అంటే గతి శక్తి స్థితి శక్తుల మొత్తాన్ని వ్యవస్థ యొక్క యాంత్రిక శక్తి అంటాం. గతి శక్తి స్థితి శక్తుల మొత్తాన్ని ఏమంటాం ఇక్కడ, యాంత్రిక శక్తి లేదా దాన్ని మొత్తం శక్తి అంటాం. సో మెకానికల్ ఎనర్జీ is equal to potential energy plus here kinetic energy, that is equal to here total energy. Okay, that is equal to here total energy. Now finally total energy is equal to half mv square minus here half mv square plus mgh. This is the mechanical energy is equal to half mv square plus mgh. We prove the freely falling body. The total energy is constant at every point. Its path, moving its path. అంటే ఫ్రీలీ ఫాలింగ్ బాడీలో వస్తువు పై నుండి కిందకు వచ్చినప్పుడు ప్రతి బిందువు దగ్గర, అది ప్రయాణించే ప్రతి బిందువు దగ్గర మొత్తం శక్తి స్థిరమని చూపించాలి. నౌ వి ప్రూవ్ ద టోటల్ ఎనర్జీ ఈజ్ కాన్స్టాంట్ ఇట్స్ పాత్ ఎట్ ఎనీ పాయింట్ ఇట్స్ పాత్. దాని యొక్క పథ మార్గంలో ప్రతి బిందువు వద్ద దాని యొక్క మొత్తం శక్తి స్థిరమని చూపించాలి. ఓకే, నోట్ దిస్ వన్ ఫస్ట్ ఆఫ్ ఆల్ యాజ్ డిజైర్ అండ్ లాంగ్ ఆన్సర్. ఓకే, here freely falling body, we prove the total energy freely falling body అంటే స్వేచ్ఛాపతన వస్తువులో మొత్తం శక్తి స్థిరమని చూపించాలి మనం. ఓకేనా, ఇన్ కేస్ ఆఫ్ freely falling body. First of all, here see diagram. This is the surface, this one here surface. Okay, this one here surface. The body of the mass or block of the mass m. It is height of this block h from the surface of the earth. ఎంత హైట్లో ఉంది ఇది బాడీ? ఎంత హైట్లో ఉంది? h height. Okay, this mass of the block here m, mass of the block or block m. Okay, this is the height of the block from the surface here h. ఎంత? How much height here? h. Okay, listen careful, very important equation part. Total height of this block here h. Now here this block freely falling, this block here freely falling. The total energy at every point its path. The total energy at every point its path అంటే దాని మార్గంలో ప్రతి బిందువు వద్ద దాని మొత్తం శక్తి స్థిరమని చూపించాలి. ఓకే, నౌ ఫర్ ఎగ్జాంపుల్ దిస్ ఇస్ a point, this one here a point. In its path at a point, for example this is a b point, for example this one here b point, or this is a final point here c point, this is a c point. 3 points here, for example 3 points its path, point a, point b, point c. The point a, height of the point a block here h. Okay, for example the distance between a and b, for example x. Okay, this distance here x. The remaining this one here h minus here x, h minus here x. Okay, 3 parts. The total energy is constant at every point in its path. అంటే ఏ ఫార్ములా వస్తుందో మనకి b దగ్గర అదే రావాలి, b దగ్గర ఏది వస్తుందో మనకి c దగ్గర అదే విధంగా ఉండాలి. ఫస్ట్ ఆఫ్ ఆల్ the total energy of the block at a point in form of the only for potential energy. Now this block to reach the point b, now the potential energy, some potential energy converting into kinetic energy, okay. Finally this block to reach the c point, the total potential energy converting into total kinetic energy. Total energy is constant. ఇక్కడ ఏంటంటే ఏ దగ్గర ఉన్నప్పుడు దాని మొత్తం ఏ శక్తి కలిగి ఉంటుంది? ఇది ఓన్లీ ఫర్ పొటెన్షియల్ ఎనర్జీ. దిస్ బ్లాక్ టు రీచ్ ద బి పాయింట్. సో పొటెన్షియల్ ఎనర్జీ కన్వర్టింగ్ ఇంటూ సమ్ ఎనర్జీ లాసెస్ ఇన్ కన్వర్టింగ్ ఇంటూ కినెటిక్ ఎనర్జీ. సో ఎట్ బి పాయింట్ హ్యావింగ్ దిస్ బ్లాక్ హ్యావింగ్ 2 energies, potential energy and kinetic energy. Now this block to reach the c point with velocity vc, for example. So the potential energy, total potential energy converting into here total kinetic energy. అంటే ఇక్కడ ఈ సందర్భం తీసుకున్నట్లయితే ఏ దగ్గర పొటెన్షియల్ ఎనర్జీ కలిగి ఉంటుంది, బి దగ్గరికి వచ్చినప్పుడు కొద్దిగా ఎనర్జీ లాస్ అవుతుంది, ఎన్లకు లాస్ అవుతుంది, అది kinetic energy లాస్ అవుతుంది. అదేవిధంగా ఏ నుండి సికి వచ్చినప్పుడు అది మొత్తం పొటెన్షియల్ ఎనర్జీ కన్వర్టింగ్ ఇంటూ ఇయర్ kinetic energy గా కన్వర్ట్ అవుతుంది. సో నౌ వి ప్రూవ్ ద total energy constant its path. Okay, when a body, listen, chala very important here, when a body at point here, at point a point ra here, first of all at point here a. Okay, matter rastunna here, some matter with diagram here, see here diagram. Symbol, arrow symbol downwards, arrow symbol here downwards. Okay, arrow symbol downwards. Point A, this one point B, this one here point C. Now at A point, now the height of the body, height of the block, the height of block, okay, the height of block at A point, at A point, at A point, sorry, at A point, H here, height of the block here, H, okay. The initial kinetic energy of the body, initial here, initial energy, initial velocity u is equal to here 0, initial velocity u is equal to 0. Now the total energy of the at A point, total energy, so potential energy at A point is equal to here simply mgh, h means here capital H means here capital H, okay. This is the total energy, this one here total energy, mgh, and here kinetic energy at A point is equal to 1/2 m v square, here v is equal to u is equal to just 0, that is equal to here 0, okay. Now total energy at A point, which point? H, total energy at A point, okay, point, total energy is equal to here potential energy plus kinetic energy, okay, kinetic energy at A point, Now this is values here substituting, simplifies here total energy is equal to potential energy means how much here, mgh plus 0, that is equal to here total energy at A point, here mgh. This is the total energy at A point is equal to TEA is equal to mgh. Now this block moving initial velocity u to reach the point B, with velocity here vb, with velocity for example vb, okay. The displacement of the particle block from A to B here x, okay. This is the displacement. Now note this one as it is, continuation, okay. Now here total energy at point when a body at B point, okay, very important, okay, at B point. Now the height of the body, nothing but block, here the height of the body from surface of the surface of the earth, how much here, h minus capital H minus here x, okay. Now the velocity of the body to reach the velocity of block at B point here VB, B point here final velocity here V is equal to here VB, okay. Now the displacement of the next displacement of block from here A to B here how much here x, here s is equal to okay x. Now this dot here s is equal to x, v is equal to vb, here u is equal to 0 and remaining terms clear, here height h is equal to here h minus x, h is equal to here h minus x. Now potential energy at B point, Now here potential energy at B point, here PE is equal to mg, here H value is mgh, okay, mgh, that is equal to PE is equal to mg into here H value is here capital H minus x, capital H minus x, okay. This is a potential energy at B point, this is a B point. Now kinetic energy of the, this is the equation, for example A, this one here equation A, the kinetic energy of the block at B point. Now kinetic here kinetic energy here at B point here of mv square of m vb square, this is a vb square. Now vb means velocity of the block to reach the point B, అంటే B పాయింట్ ని చేరినప్పుడు దాని యొక్క వేగం ఎంత, ఇక్కడ vb, B పాయింట్ ని చేరినప్పుడు దాని యొక్క వేగం ఎంతమ్మా, vb, ఓకే. నౌ here from third equation of motion, from equation here, equation v square minus u square is equal to here 2as. Now this value is here substituting. V means vb, u means 0, okay, s means h minus x, sorry, displacement nothing, displacement here s is equal to x, okay, a is equal to g, here a is equal to, next to a is equal to here g, these terms, okay. This is a here substituting, clear. Now vb means vb square minus 0 square is equal to here is equal to 2 into g into here s means x, simplies vb square is equal to 2gx, okay. This is a equation B, this one here equation B. Now equation B substituting in equation A, here, sorry, leave it, this one here, for example this one here B, equation B, this equation substituting equation B. So vb values ikkada rayandi, simply vb value substituting in this equation. After we will get the final kinetic energy of the body to reach the point B, Now note this one, finally okay, here kinetic energy at B point is equal to 1 by 2 m, vb means 2gx, this is the equation A, B, okay. This one here equation, for example kinetic energy, okay, leave it. Now total energy at B point, now total energy at B point TE is equal to here is equal to kinetic energy at B point plus here potential energy at B point. Now simplies here kinetic energy means here 2 get cancelled, this is equal to mgx, this is a kinetic energy. Now mgx plus here potential energy mgh minus mgx, any terms cancel terms here, anyone here mgh cancel. So remaining the total energy at B point is equal to here mgh. So same formula at B point, A దగ్గర ఏ ఫార్ములా వచ్చింది here mgh, B దగ్గర ఏం వచ్చింది, how much here mgh. Now finally we prove the same equation at C point, as it is matter and ఇదే విధంగా matter and continuation చేయండి, long answer, okay. Now next one, this block to reach the point C, to reach the point C, nothing but here to reach the earth, surface of the earth. The displacement of this block from A to C is h. A to C here h. The initial velocity is 0, the final velocity here Vc. The final velocity here Vc. Okay, final velocity here Vc. Now the total energy of the block at C point. Note this one. Here, when a body at C point, some matter here, when a body at C point, okay, point C point. Now the final velocity of the final velocity of block to reach the ground of the here ground and height of the ground. So Vc, velocity here Vc. Next, comma, height of block, how much height here? 0. H is equal to here 0. H is equal to 0. H is equal to here 0. And the displacement of block, okay, block, how much here? S is equal to h. S is equal to block here. S is equal to h, capital H. Okay. Initial velocity is 0. Now here S is equal to h, displacement. Initial velocity U is equal to 0. Okay. Here final velocity V is equal to Vc, and inka remaining A is equal to here G. A is equal to G. Any terms mistake inka? How much? Okay. These terms. This is a point here, this is a C point. The potential energy here, potential energy at C point is equal to mgh. Here h is equal to 0. Here h is equal to 0. Now simplifies here, potential energy at C point is equal to mg into 0. That is equal to here 0. So finally the potential energy at C point is equal to 0. At C point here is equal to 0. Now the kinetic energy of the block to reach the point C. Here the kinetic energy, now kinetic energy at C point is equal to 1/2 m Vc square, 1/2 of m Vc square. From here, from third equation, V square minus U square is equal to 2a. Yes, here V means value substituting. V means Vc square minus U means 0 square. Here 2 into A is equal to G. Here S is equal to displacement H. Okay, H. Simplies here Vc square is equal to, simply this is 0 to Gh, 2G. Yes, this is the velocity of the block to reach the ground. Vc square is equal to 2Gh. Now this one substituting in this equation. Now simplies the kinetic energy at C point is equal to of m Vc square 2Gh. 2 get cancelled. Simplies here, kinetic energy at C point is equal to mgh. This is a kinetic energy of the block to reach the ground at C point. Now the total energy of the block at C point, అంటే C బిందువును చేరినప్పుడు ఆ బ్లాక్ యొక్క మొత్తం శక్తి. ఓకే, నోట్ దిస్ వన్. కంటిన్యూషన్. mgh Finally, the total energy at C point, the total energy at C point is equal to potential energy at C point plus here kinetic energy at C point. Potential energy how much here? 0 plus kinetic energy here mgh. So simplies here T is equal to mgh. This is on equation 3. Okay, equation 3. From equation 1, from equation 2, from equation 3. These are same formulas. So total energy of the block to at every point its path is constant. It's constant. This matter as set podi ikkada variki right set podi. So from here, from equations here, equations 1, 2 and 3 are same energies, same energy. So the total energy is constant. Total energy is constant at every point, its path, okay. Path means here margam, okay. So the law of conservation of energy is proved, okay. ఇక్కడ వరకు మనకు రాయండి. వెరీ ఇంపార్టెంట్ క్వశ్చన్, లాంగ్ ఆన్సర్స్, అడిషనల్ ప్రాబ్లం వస్తుంది చూడండి మనది, ఓకే. థ్యాంక్ యూ, ఆల్ ది బెస్ట్ ఫ్రెండ్స్.